Hello and welcome to episode 32 of Samsplaining Science. I'm Sam, I'm your host. I'll be Samsplaining the science, and today we're talking about baking. Let's get into it. Hi everyone, how are you? I hope you're doing well. I'm doing well too, thank you for asking. I'm recording with my windows open today because it's a beautiful day. So I apologize for the background noise that might occur, but I'm not sorry about it because it's a beautiful day. I love this weather. I'm so happy. I love fall. It's the best time of year. Obviously, that's like a very typical basic girl point of view, but it's my point of view and it's my truth, okay? One other thing about fall, besides the absolutely gorgeous weather and the Gilmore Girls rewatch, which, by the way, I'm still trying to make it through season 1, guys. This is not a Gilmore Girls podcast, but I will just say, when I used to watch the show, like as it was coming out, I loved it. And I was like, I love Lorelai. I love Rory. I can't stand them now as a grown woman. I'm like, you both are insufferable. And the only reason, I have 2 reasons why I watch that show now. Michelle and Paris Geller. And that's it. That's it. And Jess Mariano for like a couple seasons when he's in there. Otherwise, I'm like, I can't stand any of these people. They're all insufferable. But I watch it anyway because it's like, you gotta. But yeah, it's funny how, your point of view in life changes. And then you're like, oh my God, all these people that I thought were so cool were like pathetic. Get over yourself, Rory. I gotta shift my seat a little. This is not any better, but we're gonna stick with it for a minute. But yeah, so Gilmore Girls rewatch is in full force, except not really. I'm trying to make it through season 1. Beautiful weather. Another thing about fall, that's what I was trying to say, is that the Great British Baking Show releases a new season. If you've never seen the Great British Baking Show, first of all, go watch it. It's on Netflix if you have Netflix. And basically it is a baking competition show where people, like 13 amateur bakers in the UK or Great Britain, I'm really sorry, I don't know the difference between the two. In Great Britain, they compete in a baking competition. They have like 3 different challenges each week, and then each week someone goes home. But the thing that I like about this type of competition show is that it doesn't feel like a competition show because you're like rooting for everybody, and every episode ends in a group hug, which is just so wholesome and so pure, and I love it. So yeah, I think it's like the only reality TV that I watch like ever, because it's just a feel good show. It's like, I don't know, it just makes you feel all warm inside. So yeah, it's back. I'm recording this on Friday, so there is a new episode. New episodes come out every Friday on Netflix. I have not seen this week's episode yet, but I saw the first 2 episodes of the season so far. So if you haven't watched it yet, you have time to catch up. And all of the old seasons are on Netflix too, so you should definitely go back and watch them because they're fun. But yeah, so this time of year, fall is when they put out the new episodes of Great British Baking Show, which inspired me to make this episode about baking. So if you are a fan of the Great British Baking Show, or Bake Off, whatever you want to call it, they say this in every episode, right? They say, on your mark, get set, bake, before every baking challenge. So that was my title alludes to the show. Yeah. Anyway, so once I started watching this show, like a couple years ago, I don't know, 2019, 2020, somewhere around there, I wanted to sort of take up baking as a hobby for like a hot minute, as I think many people did during like the initial COVID lockdown quarantine. And I made a couple things, and since then I've made a couple things like desserts, and I made a focaccia. But I, excuse me, I, I, when baking, I'm a curious person. I'll be asking questions. If there's one thing about me, I'm going to ask a question. So when baking, I'm always like, what is the yeast doing in the bread, right? How do we put this mixture into a metal box that's very hot for a certain amount of time, and it comes out and it's edible? Like, what's going on there? So that's what goes through my mind as I'm baking. A little glimpse into the curse that is living in my brain. But that brings us to the questions for today's episode. There are two questions this episode. The first one is, what role does yeast have in bread baking? And the second question is, how does baking temperature affect and baking duration affect bread baking? So the sources for today, I'm going to use two different research studies that answer each of these questions, and they are linked in the episode description, as always. So the first question, I'm going to reference a study led by Dr. Akbar Ali from the National Institute of Food Science and Technology at the University of Agriculture in Pakistan. This study is from 2012, so it's a little old. And it's also from the Pakistani Journal of Food Science journal, which I imagine is not a very popular journal, just because, like, food science, I don't know, like, maybe this is just my, maybe this is my, what's the word I'm thinking of? My small view of the world and the small view of science. Most of my science has been like medical sciences. So I don't really know too much about food science. I don't know how popular food science is. I don't know how in demand food science is. What's the funding like for food science? I have no idea. But there's a whole journal in Pakistan developed to food science, and that's where this article was published. So that's where I'm getting it from. And in this study, the researchers talk about different properties of bread that use different strains of yeast. They mention a couple different strains of yeast. But for me, it was just a very good resource to have a better understanding and a background of yeast and how it's involved in the bread baking process. So thank you to this paper for helping me better understand. So let's get into the question, what role does yeast have in bread baking? Yeast is a microbial eukaryote. Basically, it's a very small microorganism. It's teeny tiny, a single cell, and it is alive. Part of being alive, you've been alive before, you get it. Part of being alive is that living things need to have the ability to break down a food source in order to make energy. We call this respiration, cellular respiration, right? So we as humans get sugar, glucose, from our food, and then our cells take up the glucose and break down the glucose. And in breaking apart the glucose molecule, there are byproducts like water and carbon dioxide, but we also make energy with the breaking down of that sugar. And that's called respiration. And then with the energy that we make from that, we can use in our bodies, right? We can use it to make our muscles contract and relax. We can use it to have our nerve cells fire around. So that's how we get our energy. We break down sugar to make energy. Yeast break down sugar also, because they are also living. The process by which yeast break down sugars is called fermentation. So the yeast cell will take a sugar molecule, maybe a couple of them, and break up the sugar molecule into the byproducts of ethanol and carbon dioxide gas. And again, this is called fermentation. So let's kind of walk through the baking process for baking bread. Also, I don't think I said it yet. Some breads don't have yeast. So here we're just talking about yeast bread. I'm sorry for the closed-minded approach, but fermentation is like, sciencey. So I figured it would be a good thing to talk about on a science podcast. But yeah, so here for yeast bread, we're going to talk about sort of the steps and the science that is happening in each step of the baking bread process in regards to the yeast and what the yeast is doing. So the first step of baking bread, from what I remember, because let's be honest, I'm not the expert. I'm no Paul Hollywood. But basically, from what I remember, the first step to making bread is you mix yeast, like dried yeast, and warm water and sugar. And you make that little mixture and you just put it over to the side and you wait it out. And as you're waiting, the yeast in that mixture is going to take up some of the sugar in that mixture and it's going to tear it to shreds. It's going to rip it up to make energy. But also, it will make ethanol and carbon dioxide. And the carbon dioxide will be released as a gas. So you'll see, if you do this, that the yeast mixture will start to grow and become like a little bit bigger, take up a little more volume. And it'll grow because it's getting a little frothy, a little bit of bubbles on top. And those bubbles are the carbon dioxide that the yeast is releasing because of fermentation. So, I don't know. I thought that was pretty cool. The next step, once you leave the yeast to sit for a little while and that mixture sort of doubles in size or like gets a little bit bigger, is then you mix that yeast mixture with flour and other ingredients. So flour is a starch, and starch is like a bigger sugar molecule. It's like a super sugar. So we can digest starches by breaking the starch down into sugar and then sugar down into energy. So it's just some extra steps. And the yeast has enzymes in them, which are basically chemicals that help a chemical reaction take place. That help the yeast break down starches like flour so that more gas bubbles can be made in the dough. So you mix these mixture together and you mix the flour with the yeast mixture and like any other ingredients, I don't know, oil, eggs, I don't know. But you mix it all together and you work the dough and you knead the dough. So basically you just like mix it with your hands and like get in there and I don't know, work the dough as they call it. And that this is called kneading. And the purpose of kneading is to make sure that everything is mixed together and spread out evenly throughout the dough. And it also helps to spread the gas bubbles that were formed in the yeast mixture through the dough to make sure those are evenly dispersed as well. After the kneading step, you leave the dough again. You put it to the side and you wait. And this process is called leavening the dough or proofing the dough. And what happens here is more fermentation is occurring. So the yeast already started to break down the little sugar molecules in the initial mixture. But now that it has starches and flour, it starts to break down the flour and it continues to undergo fermentation and it continues to make carbon dioxide gas bubbles. And with those gas bubbles being produced, the dough is going to get larger. So the volume of the dough, the space that the dough takes up will be bigger as you leave it to rise or proof or leaven the dough. And then once it is, proofed long enough, which on the Great British Bake Off, people seem to struggle with, like, it wasn't proofed for long enough, or you left it to proof for too long. And it's like, well, give me a time. Give me 30 minutes starting now. But it's always just like, I think it looks good enough. When you're trying to learn how to bake, what does that mean? It looks good enough. How do I know it looks good? I digress. Anyway, after you proof it for what's the word I'm thinking of? Man, I'm having a lot of word recall issues this morning. It's because I didn't finish my coffee yet. Episode 30? What episode was coffee? I forget. Anyway, you leave it to proof for an undescriptive amount of time, undefined amount of time. That's the word I'm thinking of. See, the coffee, it helped me. You leave it to proof for an undefined amount of time. So after you proof the dough for an undefined amount of time, you can bake it. You put it in the oven for a certain temperature, a certain time, and you bake it. And we'll get into that more in the next question, but then once the bread is baked and cooled and whatever, and you slice it, there's like little holes in the bread. I don't know if you've noticed that, like when you eat bread, but it's not like a solid block of carbs. It's got little holes in it, little pores in it. And those little holes in the bread, that's where the yeast left the gas bubbles. So now you know when you eat bread, those little holes had CO2 in them. Pretty cool. I don't know. I think it's cool. You're probably like, and what, Sam? I don't have an answer for you. I just thought it was interesting. I just thought it was cool, okay? And maybe you should think that too. I'm not trying to pressure you, but maybe like appreciate the little things. Literally the little pores in the bread of CO2. Maybe you should appreciate those a little more and say, thank you, yeast, for fermenting in my bread. Okay, let's go on to the next question. The next question is, how does baking temperature and time affect bread baking? So the second study here I have linked below as well. It is a study by Dr. Ureta and colleagues from universities across Argentina and France. And they look at how the bread temperature and the bread water content changes at different baking temperatures and different baking times. So basically, part of making bread and the mixture of the bread is to mix it with water, right? So there is water in the dough. But typically, what should happen is that the dough that you put into the oven should have less water than the dough that you take out of the oven once the bread is cooked. You know, like if you're doing it right, you should have less water in the bread when you take it out of the oven. So basically they were looking at how does the water content of the bread dough change at different baking temperatures and at different baking times. So how did they do this? So first they made bread dough. They made a lot of bread dough. And they made multiple loaves and cooked each loaf at a different temperature for a different time. So they they had 3 different temperatures that they cooked bread at: a low temperature, a medium temperature, and a high temperature. And then they cooked each loaf for like a different amount of time, right? So they would cook at the low temperature, they would cook for 6 minutes, 12 minutes, 20 minutes, 45 minutes. 1 loaf per duration per temperature. So they cooked a lot of bread. And then they did the same thing for the medium temperature and the high temperature, right? Before they put the bread in the oven, or I should say the dough, because technically it's not bread until it's cooked. Before they put the dough in the oven, they weighed it. So they had a measurement of how much the dough weighed before putting it into the oven. They also had like temperature sensors in the dough at like different levels of the bread so that they could like monitor the temperature, I guess, throughout the baking process. So they like weighed the dough, put the dough in the oven, cooked it at a certain temperature for a certain duration, and then took the bread out. Immediately when they took it out, they weighed it again. So they got like the after baking weight of the full loaf. And then they sliced the bread before they let it cool. So they immediately sliced the bread, and they had this really cool like diagram schematic in the paper that showed like exactly where along the bread loaf they sliced the bread, exactly how thick the bread slice was. And then they basically dissected this bread slice and broke up the bread slice, if you're looking at it like, crosswise, cross length. What's the word I'm thinking of? Oh my God, another word recall issue. Time for some coffee. Okay. So they look at the cross section. It's magic juice is what it is. They look at the cross section of the bread slice and they divide it up into different sections. So basically, if you're looking at it, there's like a top crust, and then they get the level just under the top crust, which they call the white crust. And then the center of the bread, like the meat of the bread, if you will, they call that the crumb. And they break up the crumb into the upper crumb, the core, and the lower crumb. And then underneath the lower crumb is the bottom crust. And they have a white crust on the bottom and then the brown crust on the bottom. So they basically have particular measurements, and they, do surgery on this bread slice, cut it all up, and take weight measurements of each piece of the upper brown crust, of the upper white crust, of the upper crumb, the core, the lower crumb, the bottom white crust, and the bottom brown crust. Weigh each of those immediately after it comes out of the oven, essentially. And then, or I should say immediately after it is done baking for the given bake temperature, right? So if the bread was only in there for 12 minutes, they dissected it after 12 minutes. After the bake. They weigh it, and then they put it in a low temperature convective oven for 24 hours. And what this does is it dehydrates, or it dries the bread out. So it basically makes all of the water in that bread slice, in the pieces of that bread slice, I should say, makes all of that water evaporate. And then after 24 hours, they take each piece, each section of the bread slice, and they weigh it again. So they have a measure before and after they dry out the bread. So those are like the raw measurements that they get. But from that, they can calculate two different measures that we're going to talk about. So the first is water loss. So the water loss is based on the weight of the entire loaf of bread. So we have the measure of the mass before it went into the oven, and then after it came out of the oven. So you take that difference, make it a percentage, and that tells us the percent of water that was lost. The second measurement that they calculate is the water content. And this is specific to the dissected bread slice, right, where they had the measurements before and after drying. So they took the bread out of the oven after it was baking, they weighed the different pieces of the bread, and then they dried it, and then they weighed those pieces again. So from that, we can see how much the before and after drying tells us how much water was in the original dissected bread regions, because we can calculate the weight difference to tell us how much water was lost. So in an area or like a region of the bread that had more water, there would be a larger weight difference before and after drying compared to an area that didn't have too much water. If, all the water evaporates from a drier area of the bread, there won't be too much of a difference before and after the drying process. So that tells us like the difference, I guess, in the water content between the freshly baked bread and the dried out bread, to see how much water was in the freshly baked bread. I thought it was a clever way to go about measuring it. I mean, I'm not going to critique and review this article. That wasn't my job, but I think it's just an interesting way to try to figure out how can we measure the water content? Oh, let's just dry it out and do a before and after measurement. There's some flaws to it, of course. It's not perfect. Rarely are things in science perfect, but I thought it was an interesting approach. And I probably would have done the same thing or something similar. I can't think of anything better. So, sure, let's go with it. So, let's go to the results. So first we're going to look at the results of the water loss. So this is where the entire loaf of bread was weighed before and after baking. And they calculated the difference in weights as the amount of water that was lost due to evaporation. So I'm showing a plot in the video. By the way, YouTube, Sam Explaining Science, if you want to watch this episode. But I'm looking at figure 2 in the paper, if you want to follow along, where basically they have the baking time in minutes on the x-axis and the water loss on the y-axis. The symbols here represent the different measurements that, the different measurements of water loss as a percentage from the different loaves that were cooked at low, medium, or high baking temperature. So the low baking temperature has diamonds, the medium baking temperature has squares, and the high baking temperature has triangles here. And then each loaf was baked for a certain amount of time. So those are plotted along the x-axis, right? Where there were loaves that were cooked for 6 minutes, loaves that were cooked for 20 minutes, and so on at all of those different temperatures. So using the data at each baking temperature, they fit, which is like a math term, but they basically connected the data points to make a curve. And the first part of the curve represents the first stage of baking. And there they found that most of the heat at that point was just used to increase the temperature of the bread. Because the evaporation rate, or like the water loss, was not super steep. It was sort of a gradual increase in the amount of water lost during that time. So they all, like all the bread loaves at this point, regardless of what temperature they were baked at, they lost water in a linear fashion. So like the amount of water that they lost was directly related to the baking time. So some water was lost, but not at a super fast rate. And they found that the loaves that were cooked at a lower baking temperature, they lost water slower than the loaves that were cooked at a higher baking temperature. And the first stage of this curve, stage 1, as they called it, lasted longer for loaves that were cooked at a lower temperature compared to loaves that were cooked at a higher temperature. And then after it finishes stage 1, it goes on to stage 2 of the baking process. So stage 2 is the second part of the baking process. And there they found that the heat was used to actually make the water evaporate from the dough, from the bread loaf, right? So the pattern here on this curve at stage 2 is a more exponential change in the water loss. So you'll see that it's no longer a straight line, it's actually curved. So the water loss increases more rapidly until it reaches a plateau. So it's a little more curved, and then eventually at some point in the baking time, it reaches like a sort of a plateau where it doesn't lose any more water. And this happened at around 18 to 20% water loss, regardless of where or what temperature they baked the bread at. However, it's important to note that it took the low temperature baking bread longer to reach the 18 to 20% water loss plateau. So they actually had to cook the bread at a lower temperature for almost 80 minutes. So almost double the time in order to get a similar water loss compared to the breads that were cooked at like middle or medium and high temperatures. Okay. So that's water loss. Now let's go on to the water content, which again was where they dissected the bread and they weighed it before and after drying to figure out how much water was in the bread right after the baking process. So the graph that's shown here in figure 5, if you're following along, is shown for the results of the medium baking temperature. And they show it across different baking times. So baking time is on the x-axis again. The y-axis is the water content as a percentage. And the data here, again, are only for the medium baking temperature, and they're shown for each of the regions of the bread slice. So remember, like the upper brown crust, the upper white crust, upper crumb, core, lower crumb, and so on. So here, it starts out all the same, because it's like all the same dough. So at baking time 0, the water content at each point of the bread slice is the same. However, as the baking time goes on, as you bake the bread for longer, you can see a separation where the crusts separate from the crumb, or like the middle of the bread, right? So the crusts all lose water content as you bake the bread for longer. However, the part of the crumb, the middle of the bread, doesn't lose the water content as quickly, and actually in some cases doesn't lose any water content in some places, but it certainly doesn't lose as much as the bottom crust and the top crust does. So basically what we're seeing here is that the water content of bread changes most in the crusts and not so much in the core of the bread and the crumb of the bread, regardless of baking time. So putting these two together, the water loss and the water content, we know that bread loses water as the baking time goes on, so we can assume here that the water content is changing more in the bottom crust and in the top crust, so maybe that's where the water is being pulled from and evaporated from, if that makes sense. The researchers also note that this plot here was not affected by baking temperature. So all of the baking temperatures, whether it be low, medium, or high, they all sort of had the similar pattern or progression of water content changes throughout the baking time. So all of them had a decrease in water content as the baking time got longer. So just some conclusions to pull this study together. What does the data tell us? The data tells us that water loss increases with baking temperature and time, and that the water content decreases with baking time, and it's lower in the crust and higher in the crumb. So just some, like, why does it matter? Who cares? I mean, I don't know. I feel like you probably asked that a lot. Like, Sam, who cares? I care. People who bake care, right? People who are looking to bake more sustainably, right? If we want to use less energy and cook at a lower temperature, but also less time, like if we're trying to optimize the baking protocol so that we can use less energy or use less time, we care about the kinetics of bread baking and how high we should set our oven and how long we should leave it in for, so that we can, one, get a good piece of bread, but also, make sure that it's cooked efficiently. So the answer is that I care. Maybe you care too. Maybe not. I bet Paul Hollywood would care. If I ever meet Paul Hollywood, I'm going to talk to him about the water content of the crumb of the bread. That'll be a good conversation starter. Okay, so that's question 2. How does baking temperature and time affect bread baking? Hopefully with that, we have a better idea of how the oven and the time spent in the oven affects the bread, specifically the water content of the bread. Because you certainly don't want your bread to be too wet. Wet bread is disgusting. Even thinking about it is ugh. But yeah, so hopefully we have a little bit of a better insight as to baking temperature and time and how it affects bread baking. All right, I want to get into some closing thoughts for this week's episode. So the first one, really the main one, is just now you know. I feel like a lot of the episodes of this podcast have like a greater purpose, like a significant meaning, like the climate change episode, like, you know, a lot of episodes have like a purpose, and it's like, we got to take this seriously. But this is like, hey, if you're curious, this is why yeast make bread rise. I don't know. But now hopefully. Maybe you've learned something today. I hope you've learned something today. But it's not going to change your life. It's not going to save your life. It's not going to make you look at the world differently. It's just like, it'll make you look at bread differently, maybe. I hope. Wouldn't that be nice? That would be pretty cool. Just an appreciation for baking and yeast and the water content of bread. It's the little things you got to appreciate in life. Also, it's keeping with the theme of my life, and certainly of this podcast, that science is everywhere. You cannot escape it. It is in every single thing that we do, even hobbies like baking. It's everywhere. And as a scientist, I certainly can't enjoy anything without finding science in it and finding a way to make it science. It's a blessing and it's a curse, and it's the way that I live my life, and I wouldn't change it. But yeah, just remember, science is everywhere, even in baking. Take that, Prue. We love Prue, by the way. We stan. All right, that's all for this week's episode. Please don't forget to follow, rate, and review the podcast wherever you're listening, and you can subscribe on YouTube, please. You can also follow the show on Twitter and Instagram at samsplainingsci, and on TikTok as well. So you can connect with me there and ask questions if you'd like. You can submit your questions at samsplainingscience.com/ask. So if you have anything that you want Sam explained to you, ask away. Thank you so much for listening to this week's episode. I hope you learned a little bit and laughed a little bit, and I will talk to you next time. Bye.